Hello friends, it's me again. My kids are downstairs playing, so don't be surprised if you hear the little kids screaming at each other. Probably a dinosaur fight. Maybe Legos. I'll tell you if it happens. um, so what I'm going to do in this video is just walk through, draw the circuit for you for week 2, and then we're actually going to construct it and test each part as we add it, just so we know that each part works as we're building it. There's too many times where I've either done this or students done this where you build the entire thing and you think it's great and then it doesn't work, and then you have to sort through the rat's nest to figure out where the problem is. So we're gonna draw part of it, make it, test it, draw the next part, make it, test it, and go through each one. So the first thing we're gonna do is one of these photosensitive, can I get it to focus? Probably not. Photosensitive resistors. And the way that we're going to set it up is we need to supply 5 volts to one side of the circuit, ground to the other, and then we're going to measure a voltage in the middle. So if we were to draw that, we're going to, just like I said, 5 volts up top. We're going to have our photosensitive resistor. There's a few different ways to draw that. It's usually a resistor symbol, circle around it, arrow coming in, lights shining on it. Depending on the device, you might see different versions. Sometimes it's like a rectangle inside there, but there's some light shining down on it. And then from here, we're actually going to, this is where we're going to hook up our pin for measuring. And we'll do pin 0, so pin A0 on this one. And then we need another way because we want to measure, we want to measure voltage, and it needs to be somewhere between 5 volts and ground. And so we need to supply the other ground part, and we want to put, in this case, a specific resistance. No matter how I draw this, it always looks weird. And this is going to be 0 volts or ground at the other end. So what I'm going to do, this is the photosensitive resistor, and this is this one is going to be our 10K ohm resistor, which you should have a bag full of, there we go, 10K ohm resistors, and they have a color code on them. I've shown you the app on my phone, but these are nicely labeled, and you only get two values in the kit. And so this one is brown, black, orange. So let's start with ground, right? First we'll grab a wire, and we'll go from ground to ground on the board. Just so now that whole vertical line is connected to ground. And then we'll connect ground to where we're going to plug in this resistor. So that bottom row now is connected. And I'm bridging across, so that's a separate line that I'm connected to. Oh, if I can. New breadboards sometimes are hard to work with. It's good. It's making a good connection, but it sure is frustrating when the pins bend. Okay, so now we've got, it's connected to ground to the resistor. And then I'm going to do the top half of this circuit, which I just need to connect it to 5 volts, this photosensitive resistor. So I'm going to connect here and then go up a couple pins. And then I'm going to connect the other side of that photosensitive resistor to 5 volts, which I haven't hooked up yet. But I will now plug in this red wire to 5 volts and plug it into the red column there. So now I've got the photosensitive resistor circuit. I didn't plug in the analog pin yet. I'm going to use one of these yellow wires, plug into A0, and then I need to plug it into where the resistor meets up with the photosensitive resistor, which is over on this line right here. And so now we've got our photosensitive resistor circuit. I go back over to MATLAB now. This is the code from the lecture. But if we wanted to just read that voltage, let's leave that line there and get a new line here. So I'm gonna again want to address my Arduino object, and then I can go back over to the read voltage documentation page, and I'll zoom in again. Again, you're supplying the Arduino object, which I'm doing with the dot syntax before it. So I'm going to say dot read voltage. And then I need to pass it the pin number. If we go back, this is either a string or a character array. We use double quotes, which makes it a string in MATLAB, and pass it A0. And now while it goes through here, I'm going to change this down to 10 seconds. While it goes through here, I'm going to see the voltage read from this circuit if I've done everything correctly. So if we run this, I grab my cell phone and shine some light. So you see a different voltage showing up. I shine a light on it, and the voltage goes higher. I take the light away, the voltage goes down. So if we go back to the circuit real quick, that's telling us that this particular photosensitive resistor, as we shine more light, the resistance is getting smaller, and so we're getting closer to 5 volts. If you wanted more of a range, we could have picked a different value for this particular resistor. So let's do that real quick. Let's take out the 10K ohm. Put that back in the bag so that we know which is which. You can memorize the codes, fantastic. If not, keep them organized. If not that, get one of the free apps for your phone. So this one is one of the 330 ohm resistors that you get. Orange, brown, sorry. And then we plug that one in instead. And so now we're going to get a different range, right? Because we just replaced this with a smaller value. And so we'll be able to get much closer to ground when it's dark. So if we were to run this, let's head back over to MATLAB. Get my cell phone flashlight on first, and then run this. So we're seeing something just below 1 volt. I shine a light on it. We see it jump up quite a bit. If I get really close, you can see it go even higher. So for this one, 330 ohm works better. Let's go back and fix that on this circuit. It'll give us a better range to work with for the lab. So we have a 330 ohm resistor on there now, and so we get values that, depending on where it was, let's run it again, because I think if I were to, the way you can get opposite is by putting your finger over it. Yeah, we get all the way down to 0.2 volts, whereas with the light, we were getting upwards of 3.5, roughly 3.5 volts. So much wider range than we were seeing for the 10K ohm resistor, which was between like 4.25 and 4.8 volts. So with the smaller resistor, we'd hopefully capturing more of the entire range. So we've got a force sensitive resistor now. That's great. The next one up we're going to do is the temperature sensor, tiny one. So this is, again, kind of the half hemispherical or the half cylinder shape. And it helps if you kind of pry the side legs away just a little bit. And then what I'm gonna do, so you can see it a little better, is I'm going to put those 3 legs in to 3 consecutive rows, just like that. And I'm going to take that back out and move it over one so it's easier to plug into. And now if we were to pull up the page for that, give me 1 second. All right, so this is the data sheet for this sensor. And this bottom one right here, it's showing the flat side. So pin 1, and if we look at the circuit board, my pin 1 will be up top here. That'll be the voltage that we want to supply, so 5 volts. The middle one will be our output, so pin 2 is our output. That's what we want to hook up to an analog pin. And then pin 3 will be ground. And so if we look at what that circuit is, let's scroll down a little bit. We've got the temperature sensor. We're going to put this one to 5 volts. Make sure I do this right. This one to ground or 0 volts. And then the middle one we're going to hook up to, might as well go with the next one, pin A1. Right, so this one's much easier because all that entire circuit is built into this device. And so we don't need to hook up any additional resistors or capacitors or anything else. We can just power or 5 volts ground and then measure the signal. So if I push that forward a little, first we'll plug in 5 volts here. So grab it from, again, this vertical line that we have over on the side. New breadboard. And then plug it into the top pin. Let me switch views here for you. There we go. And then I'll use a different color. We'll go green to ground and do to the bottom pin. And you'll know if you hooked it up incorrectly if you do that and it starts to get hot. Ooh, hello. Did I just do it backwards? What? This is exactly what the... Oh, that's the bottom view. Oh, I had it flipped. Make sure you read the data sheet. So I did mine backwards. You can tell when it gets really hot when it's backwards. Make sure you read the data sheet. And then we'll grab, just like I said, let's go back to the bigger view. Pin A2 here, and we'll hook up to that middle pin. Temperature might still be a little high when we read it because I almost burned out the sensor, but saved it at the last second there. So let's see, we've got, we're reading A0. Really all we want to do is make sure that the temperature sensor is working okay. Hopefully I didn't torch it and I have to use one of the other ones. But now we can just change that A0 to A1 and run it. And we'll get a voltage. And if I lean over and grab hold of it, we're not going to see a huge increase, but we should see it go up. Yep. You can see it went from about 0.71, which was slightly higher than room temperature because, again, I made it heat up. And then up to body temperature, which is around 0.74 volts. So 0.71 to 0.74. If we go to the data sheet, we actually can see that, scroll down. Performance characteristics. I don't know if we'll get it out of this because they probably don't specify for 5 volts. Well, output voltage. TMP 36, we're looking at B. And temperature, room temperature is around 20. Yeah, so around 0.7. And then body temperature is 38. So we should have seen it go up and beyond point. Here, let me zoom in on that. So temperature, we're looking at line B. B is the TMP 36. And so if we look, room temperature again is around 20 degrees Celsius, a little hot in this room at the moment. So maybe between, right around here, so 0.7, and then going up to around 38, we should have seen, if it was able to measure my body temperature and my hands are not cold, then it should have been just above 0.8, maybe upwards of 0.9. So let's try that again, maybe for a longer period of time. Run it again. Get room temperature. It is going up very slowly. I don't have the greatest grip on this thing. It would get there. Usually hot breath works fairly well. Good news, you can't smell my coffee breath. So we got it to go up to almost 0.8. Assume sitting for a longer period of time would have gotten us a better response out of there. But we're seeing in the right range of values that we should for the sensor. Again, probably wasn't fantastic that I hooked it up opposite, but it is what it is. The last one we're going to do for sensors is the force sensitive resistor. And this one, just like the light sensitive resistor, we need to include another resistor in there so that we can push it further or closer to 5 volts. So going back to this, let's move this over just to here. And then for our circuit, one second, one node is not working. All right, so for the force sensitive resistor, we're going to have, again, 5 volts come in. We're going to have our force sensitive resistor, which, gosh, for a force one, I don't know what the symbol is. I assume it's similar to the light-based one. Now I got to look it up. I'm back. It's just a line through it. Sometimes with an F next to it. Easy to remember. And then we're going to hook this. Let's draw the other half of it first. And then we're going to have a resistor that goes down to ground, or 0 volts. And then in the middle, we're going to measure with pin. I've got A0 and A1 used already. We'll use A2. So when I push on this, when I squeeze those foam cells together or apply it, depending on the material that's in whatever force sensitive resistor you have, reducing the resistance by kind of making more contact within the material, you're going to have lower resistance, so we're going to get closer to 5 volts because that resistance is going to go down. So we'll plug in up here. And then we just need 5 volts, which we'll plug in to one side. We need a resistor to go in there. I believe the 10K ohm one is the better one to go with for this. So we're going to grab another 10K ohm, the brown, black, orange resistor, and just jump across here. So plug it in, bridge to the other side of the circuit board, and then another green wire from that resistor to ground. You can't burn this one out. Well, not easily anyway. And so now we've got a force sensitive resistor. If we head back to MATLAB, we can now read from A2. So let's read that value. Getting values, I can squeeze on the resistor. No change. Did you catch the mistake? I never plugged it into the analog pin. All right, let's go back so you can see that. A2 jumping through what is now becoming a pretty good rat's nest over to the same line that's shared between the resistor and the force sensitive resistor. So now we're connecting, just like in the drawing, we're connecting right on the same line as those other two. So now when we go back to MATLAB and we run this again, zero, we start pushing on a little bit, it starts to shoot up harder and harder, and then we get all the way upwards closer to 5 volts. See if I can get it. Not gonna happen. All right, so we get effectively like the full range of values for those, and then each one of these sensors, at least the force sensitive and the temperature sensors, have a conversion that goes from voltage to either degrees Celsius or some applied force. I think the data sheet shows it in newtons, but we can we'll get to that in the lab. Then the last part is one I think I'm gonna have to grab a picture for, is it's actually this motor driver, and this is what we're going to use along with analog right, or the right PWM voltage. We're going to use those two together and allow us much finer control over when the motor is on or off. And so we'll be able to specify like 10% duty cycle, and we'll see a much slower speed than if we just turned it on full board. So I'm going to grab an image real quick and I'll be right back. All right, so what we have to do is hook up multiple wires to this circuit board so that we can drive it essentially. And the ones that we're going to start with are the power pins, the ones that are important for supplying power, and also kind of the reference voltage that's used so that the board knows what logic is being applied. And those are, grab the right color here, and blue will work. VM is the voltage for the motor. VCC is the one from the board, our 5-volt supply. We need to supply a connection to ground in a couple locations. And I guess they've got 3. I'm guessing on the board those are all connected, but we're going to connect at least 2 of them. And then what we need to do is then use 3 of the pins from the Arduino board to control what's happening with the motor. And then from there, we can supply, these 2 are out to motor. And once we have part A hooked up, then we'll be able to do part B more easily. because it's just supplying the same type of 3 pins for those. But we're going to first test the motor for A. And what we can do, again, I'm going to start with ground. Lost my wires, 1 second. All right, so I'm going to grab 2 of the black wires, and then I'm going to connect from ground in both cases. So over on the side, and then connect to the ground on the 2 bottoms. Right? And then next up, I need a voltage from the board, the VCC. So the second down on the left. So I'm going to grab from 5 volts, again on the side here, and go over to VCC. Now, I'm going to end up supplying the motor from a battery pack eventually. But what I'm going to do just for testing the motor at slow speeds, because I don't want to demand too much from my USB port, is I'm going to plug the 5 volts into, what I'm going to do first is unplug the USB. I'm going to, yep, there we go. Plug the V motor, the top left one, into the 5 volts for the board. So again, just grabbing from 5 volts over here, bring it over to VM. And then the next thing that I need is, I could hook up the motor now, but nothing will happen to it. What I need is 3 signals from the board itself. And let's switch views here. So this is the motor driver data sheet. And this is the control functionality. So we need 2 input signals that are just on or off to tell it if it's braking or if it's moving in one direction or the other. And then the PWM, the pulse width modulation signal, essentially tells it how much to be on or off, or like how quickly to move in that direction or the other direction. And so we need 2 regular pins. The ones, I wrote these down so I wouldn't change them. The ones that I'm going to use for just the base inputs for part A are digital 4 and digital 5, so D4, D5. And then the PWM is going to be D6, and D6, 5 is too, but D6 is one of the, move it over. D6 is one of the ones with the tilde next to it, which means that it's pulse width modulation capable. So if we go back to the board view, now I'm going to just grab some different ones here. I'm going to grab 2 yellow for the on-off, like in which direction, and that's my A1, AI2, and this one's going to go out to, well, AI1 is going to go out to D4, AI2 is going to go out to D5, and PWMA is going to go out to D6. So I'm going to use the 2 yellow for the inputs. So the AI1, it's hard to do with this camera in the way, is going to go to 4. AI2 is going to go to 5. And then AI6, or sorry, PWMA is going to go to D6. And I used a red one for that. I'm going to use a white one just to make it more clear. All right. So now we've got everything that we need to tell that board to move motor A forward. So I'm going to take one of the motors and I'm going to plug it in over here. Like I said on this drawing, to A01 and A02. So again, the motor here. And I hope you can appreciate now when I said it starts to look like a rat's nest. This is what I was talking about. There are different wire kits. I've got some of them. So wire kits like these make for much cleaner, like neater, easier to follow breadboarding experiences. It's these, I think it's like $5-10 for one of these on Amazon. You can find them cheaper if you want to pay for shipping. But these are the ones that we have are good enough for now. It's just obviously makes it a little harder to follow. So what we can do then, now that we've got that, is go back over to MATLAB. And I've got those 3 pins, right? And if we go over to the data sheet, what's a simple case I can test? Well, in 1 is low, in 2 is high, and then we can use the pulse width modulation to go counterclockwise. So let's try that. Let's say, let's comment out this while loop. We'll come back to that. So let's say my Arduino object, and then we need to turn D4, which going back, again, D4 is the one or in 1 signal. So write digital pin, and we pass it a pin number, so D4, and then a value. And in this case on the data sheet, I'm just testing counterclockwise. I want the low signal, so 0. That's off or false. And then do the same thing, write digital pin, and I'm gonna send it to D5, which is the one that's hooked up to my input 2 for motor A, and 0. And then lastly, I can set a speed by using the write PWM voltage. And so I can say my Arduino object, again, we have an example right down here, write PWM voltage, and pass it the pin number. In this case, it was D6 that we were going to pass it to, and we want to pass it some voltage. Let's keep it relatively low. We'll say 1, so it's like 20% power, just because I don't want to cause my USB port to fail. And we'll turn it up eventually and see if it actually does that. So we've got a 1 there. I don't know how much current these motors draw, so that's why I'm saying that. So if we run this now, nothing should happen, right? Oh, I can't. Never mind. Let me plug it in. Arduino detected. Good. Not drawing too much current yet. Let's see what happens when I hit it run. Nothing. Interesting. Let me unplug. Maybe I shouldn't have guessed that they had their grounds connected. Do one more ground wire to that 3rd ground pin that I didn't connect. So important thing from the data sheet, and I remember seeing this. Where is it? Standby. There's a standby pin. You have to have, I believe it's a high signal on the standby pin, which we don't have at the moment. You have to have a high signal on the standby pin to make it go. So let's go 5 volts. Again, the red column over to the standby pin. All right, give it another go. Switch cameras here. Anything? Nothing. Did it run? Totally ran. Interesting. It's possible that 1 volt is not high enough. Let's get crazy. It's, you guys best see this. Changing it to 3 volts. Put a pause in there as well. Nothing. Interesting. Give me a second. Let me figure out where I wired it wrong. I'm pretty sure I figured it out. Nothing's wrong with the wiring. Well, let's see. Maybe nothing's wrong. We need a high signal on that second input pin. Look what I got here. I got a 0. I need that to be high. Oh my gosh. Let's get to keep going. So your board will continue to do the last action that was programmed, or that it stopped at for the program. And my multimeter on. So it will continue to run at 3 volts. And apparently you can power this with your USB. 2 motors, I would guess, would not be okay. But let's do something real quick just to test the different speeds. Let's say, well, talk is less than 5. We're going to, we'll even say something slightly less, 4.9. Let's write the voltage. Let's write the time as the voltage. So we'll say my Arduino object dot write PWM voltage to pin D6 and write talk. So that's the amount of time that's elapsed, and it will return as a number, and then we can say end. So if we run this, slowly speeds up and goes max speed. And makes a lot of noise on your desktop. Ways you can stop it, hit the reset button. So that's it for the wiring. We've now, or no, it's not. We got to wire up the other motor. All right, so we'll get the other motor out. Get it out of your bag. We can hook this one. I'll be the test here. to see if it's okay to plug this into. I just heard the USB disconnected sound. All right, let's unplug the USB cord or plug in anything. And then plug in these 2 wires down where motor B goes. And then we need 3 more wires now to go to the control pins for B. And so on these ones, I said for in 1, I'm going to say this is D8. In 2 is D9. And then my pulse width modulation, again, I had to make sure I chose a PWM capable pin is D10. So let's grab, again, I'll grab 2 yellows and a white, just like I did for the other one. The 2 yellows will go to 8 and 9. And those go 8, which is this one, goes right here to BI1. And then 9 goes to BI2. And then my white one is going to go from D10, which is PWM capable, all the way over to PWMB. So now if I put these 2 motors here, I'm just going to slide the board over. Or better yet, we don't need the circuit anymore. Get that out of the way. You can see both motors. Plug in my board. Now we need to supply something, going back to the code quick, we need to supply something for 8, 9, and 10. So let's say, oh, I got an easy one. Let's copy these first 2. Just have it go the same direction. And switch these to pins 8 and 9. And so those are the ones that are signaling which direction to go or to break. And then in here, instead of D6, or we'll keep D6, but then we'll add another line where we say for D10, let's actually do the opposite, where we're going to start at full speed and then ramp down. So 5 minus torque. And we'll save that, and then I can switch views for you guys again. So one should start really fast and get slower. The other one should start slow and go really fast, and then go faster. So let's run this and see if the USB chip in our laptops can handle 2 motors at the same time. So one's going, slowing down, and then the other one's up to full speed. Again, reset button if you don't want the motors to continue this. Otherwise, reset button or say clear all in MATLAB, which you didn't get to see because I didn't have it up. But clear all in MATLAB will clear that connection out of there, effectively resets the board if the reset button is hard to get to. All right, that's everything for wiring up week 2. Photosensitive resistor, temperature sensor, force sensitive resistor, and then the motor driver for the 2 DC motors. That's all I got. See you guys later.